Space, the final frontier. And well, YouTube's wildest theories. Space exploration captivates us all. It's a realm of mystery and wonder. We yearn to know what's out there. Are we alone? Are there other planets like ours? YouTube is full of videos claiming to have the answers. Some show strange objects in space. They say these are proof of alien civilizations. But are these claims true? Not always. I'm thrilled by the public's fascination with space. But I'm also concerned by the spread of misinformation. It's crucial to distinguish between exciting possibilities and actual scientific findings. Real space exploration relies on rigorous observation and testing. Discovering planets around other stars, exoplanets, is a major area of astronomy. These discoveries help us understand if our solar system is unique. They also raise the possibility of finding life elsewhere. But how do we find these distant worlds? Scientists use several ingenious methods. One method is the transit method. Imagine a planet passing in front of its star from our viewpoint. This planet will block a tiny amount of the star's light. We can detect this dip in brightness with telescopes. The Kepler Space Telescope used this method to find thousands of exoplanet candidates. Another method is the radial velocity method. A planet's gravity tugs on its star, causing the star to wobble slightly. This wobble creates tiny shifts in the star's light spectrum. By analyzing these shifts, astronomers can infer the presence of an unseen planet. Spectroscopy is another powerful tool. When a planet transits its star, some starlight filters through the planet's atmosphere. This leaves a fingerprint on the starlight. By analyzing this fingerprint, scientists can learn about the composition of the planet's atmosphere. This can tell us if a planet has the ingredients for life as we know it. The vastness of space fuels our imagination. It's tempting to see patterns and meaning where none exist. This is called pareidolia. It's the same phenomenon that makes us see faces in clouds or animals in random shapes. YouTube is rife with videos claiming to show evidence of alien life based on blurry images or misinterpretations of data. One persistent claim is the existence of alien megastructures. These hypothetical structures are so vast that they could harness the energy of an entire star. Some YouTubers point to unusual fluctuations in a star's brightness as proof of these structures. They suggest that advanced civilizations are building these megastructures around stars. Another famous example is the face on Mars. In 1976, NASA's Viking 1 orbiter captured images of a region on Mars called Cydonia. One image showed a mesa that resembled a human face. This sparked widespread speculation about ancient Martian civilizations. However, higher resolution images taken later revealed that the face was just a trick of light and shadow. These claims are often presented with great conviction. They use scientific-sounding language to sound credible, but it's crucial to remember that extraordinary claims require extraordinary evidence. Before we jump to conclusions about aliens, we need to exhaust all other explanations. Let's take a closer look at two popular space myths and how scientists debunked them. Tabby's star, also known as KIC 8462852, gained notoriety in 2015. The Kepler Space Telescope observed strange dips in its brightness, much more dramatic than those caused by typical exoplanets. Some speculated that these dips were caused by a giant alien megastructure orbiting the star. However, further observations and analysis revealed a more mundane explanation: dust. Astronomers now believe that a ring of dust orbiting Tabby's star is the most likely cause of the unusual light patterns. The face on Mars is another case of pareidolia, leading to wild speculation. The initial low-resolution image from Viking 1, taken with the sun at a certain angle, created the illusion of a face. However, subsequent images taken by the Mars Global Surveyor and other missions, with better resolution and different lighting conditions, clearly showed that the face was just a natural mesa. The human brain is wired to see patterns, even when they don't exist. These examples highlight the importance of skepticism and further investigation. Science is a process of constantly testing and refining our understanding. While it's tempting to get caught up in exciting possibilities, we must let evidence guide our conclusions. The power of peer review, separating fact from fiction. Science is a collaborative process. Scientists don't work in isolation. They share their findings with the scientific community through peer-reviewed publications. This means that before a scientific study is published in a reputable journal, it's reviewed by other experts in the field. These experts scrutinize the methods, data analysis, and conclusions. They check for errors, biases, and flaws in reasoning. Peer review acts as a filter, ensuring that only high-quality, reliable research is published. It helps to weed out flawed studies, unsubstantiated claims, and outright pseudoscience. When you read a scientific finding published in a peer-reviewed journal, you can be confident that it has undergone rigorous scrutiny by other scientists. YouTube videos and other online content often bypass the peer review process entirely. Anyone can upload a video claiming to have made a groundbreaking discovery. Without the checks and balances of peer review, it's much harder to distinguish between credible information and misinformation. This is why it's crucial to be critical of what you see online. Look for evidence, sources, and whether the claims have been vetted by other scientists. The universe's true wonders, more amazing than fiction. While it's important to debunk myths and misinformation, it's equally important to celebrate the incredible real discoveries made by scientists. The universe is full of wonders that are far more awe-inspiring than anything we could make up. Consider black holes, objects so dense that not even light can escape their gravitational pull. Or neutron stars, the collapsed cores of massive stars, where a teaspoonful of matter weighs billions of tons. Think about the vast cosmic web of galaxies, stretching across billions of light years, each galaxy containing billions of stars, many orbited by their own planets. The more we learn about the universe, the more mysterious and awe-inspiring it becomes. We've discovered planets that orbit two stars, like something out of Star Wars. We've found evidence of organic molecules in interstellar space, the building blocks of life. And we're constantly pushing the boundaries of our knowledge, peering deeper into the cosmos with ever more powerful telescopes. Curiosity, skepticism, and the spirit of exploration. The human desire to explore is what drives us to understand the universe around us. It's what led our ancestors to sail across vast oceans and explore new continents. And it's what inspires us to send probes to other planets and telescopes to the edge of the observable universe. Curiosity is essential for scientific discovery. It's what makes us ask questions, seek answers, and challenge existing knowledge. But curiosity without skepticism can lead us astray. We must be willing to question what we see and hear, especially when it comes to extraordinary claims. The beauty of science is that it's self-correcting. Over time, through observation, experimentation, and peer review, we refine our understanding of the universe. We discard theories that don't hold up to scrutiny and embrace those that do. It's this process of continuous questioning and exploration that has led us to our current understanding of the cosmos. Conclusion: embracing evidence in the age of information overload. We live in an age of information overload. The internet gives us access to more information than ever before, but it also makes it easier to spread misinformation. This is especially true when it comes to topics like space exploration, which captures our imaginations and inspires both wonder and speculation. It's essential to be critical consumers of information, especially online. Don't just believe everything you see or read. Ask questions. Demand evidence. Be wary of sensational claims, especially those that contradict well-established scientific knowledge. The real story of the universe, revealed through the rigorous methods of science, is far more fascinating than any fiction. Let's embrace the spirit of curiosity and skepticism, and continue to explore the cosmos with open minds and a thirst for knowledge. The universe is full of wonders waiting to be discovered, but we need to be careful not to let our imaginations run wild and cloud our judgment. By grounding our excitement in evidence and critical thinking, we can ensure that our quest for knowledge leads us to a deeper understanding of the cosmos and our place within it.